Yeah. I think few more people have joined. Next. Um, the classical mechanics, we will continue a few days later. Today also, you are having the class from 7 to 8:30 only. Tomorrow onwards, you will have class, two classes, one from 7 to 8:30 and next from 9 to 10:30. Fine. Before going to the electrodynamics, electromagnetic theory discussion, I would like to give you some idea about the previous net cutoff marks. We should know what mark has to be obtained to qualify net or JRF. All of us know that total number of questions will be there 75 questions. Out of the 75, the compulsory means you can attempt a maximum 55 questions, and maximum mark is 200. And to qualify net or JRF, as Dr. Harikrishnan mentioned yesterday, this no need to write all the answers, no need to attempt all the questions. Only a few questions we have to attempt. Sure questions. Just I will give some brief idea about the cutoff mark of the previous net JRF exam. I will share my screen. Am I audible? Any issue? Any voice, video, any issue? Anyone, please?
Yes, sir, it's audible, sir.
Okay, fine. Okay, thank you. Is it visible? Can you see my screen now? I shared a new screen.
Yes, sir.
Okay. Thank you, understand. Okay, fine. This is a previous year cutoff mark. I switch off my video for better. Yeah. Here you can see this is a CSIR and physical science cutoff mark percentage. JRF to this column JRF, and this is a lectureship. These columns. This is for JRF mark. Let us look at the 5 years, last 5 years mark distribution. For unreserved category, that is in December 2022 and June 2023. Actually, that was one exam. 39%. This 39% means that it comes around the 71 mark. Mark is 71. That is out of 200. If you get 71 mark, you will qualify JRF. Okay. Whereas in the lectureship on the same year, that is for unreserved category, 35.77%. It's around the 7%. This 35.7% comes around. Sorry, there is some. Actually, this is 39% comes around 78 mark, and 35% comes around 71 mark. There is a difference between the lectureship net and JRF. That is very small mark. Here it is 78, here it is 71. Only 7 mark difference is there. Then if you go to the previous year, that is June 2022, that is unreserved category 50%. 50% as you know, this come around 100 mark. Because if the exam is very simple, the cutoff mark will increase. I am talking about unreserved category only. The maximum cutoff mark goes to the unreserved category. Others, OBC is lesser, with a small percentage compared to the unreserved category. In all the case, the OBC and other category have the lesser mark, lesser percentage. Okay, here, if you are OBC, a lectureship, you need to get 33% only. 33%, it means is 66 mark only. Okay, that is then if you go to the June 2022, it is 50% mark, then it comes around 100. For net, that is around 45%. Okay. Then in June 2021, June 2020, if you go through this picture, the largest, the maximum mark or the highest mark was on June 18th. That is around 55%. 55% means that it comes around 110 marks. No other years, the qualifying mark is small compared to the this June 2018 mark. Okay. And that year, for net, for qualifying net, the cutoff mark was a little bit high. Okay. Then, if you go through this mark percentage, we will come to know that if you secure 100 mark, that is, if you answer the correct questions, if you mark the correct answers for 100 mark, you are in safe zone. That Dr. Hari Krishna mentioned yesterday. Then this 100 mark means out of 200, we need to get 100 mark. Then we are in a safer zone. There is a greater possibility to get JRF. Okay. If 10 or 5 mark lesser than this, maybe 90 for the net. Okay. These statistics shows that no need to answer all the questions or no need to try to bubble all the questions that will attract negative mark. Instead, you learn few topics very thoroughly and do all the problems from that topic, then definitely you can earn at least 100 marks. Okay. Another thing, all of you might be knowing about the part A, part B, part C questions. For part A, you will have maximum 20 questions. You have to write maximum, you can attempt 50 questions only. Okay, maximum you can attempt 50 questions. Then part B, you will have 25 questions. You can write 20. Part C also 25 questions, you can attempt maximum 20. And also part A, each question carries 2 marks. Part B, each question correct answer carries 3.5 mark. And part C, 5 mark for each correct answer. Then if I say the part A, that the questions comes from the general aptitude. Each question carries 2 marks. Then if you write at least eight question from part A, then you will get 8 into 2, 16 mark. Part B, out of 20 question, you answer half of the question, 10 question. Then 10 into 3.5, you will get 35 mark. In part C, also no need to write all the questions. Out of 25, you can write around 10 questions. You can answer 10, 10 questions very uh, accurately. Then you will get 10 into 5 is 50. This 50 is 35 and 16. Then you will become 85 and 101 mark. Okay. This calculation, what I would like to convey from this calculation is that out of 25 questions from the part C, if you write 10 questions correctly, and from part B, out of 25 questions, if you write 10 answers correctly, and from part A, that is for an average student, he can correct at least 5 questions from part A. Part A is also very important. Don't make it as a don't ignore this part A. You have to try to answer a few questions from part A, and you also practice the questions. There at least 5 questions one can answer. Even average you can answer 5 questions. Then if you have then in each part, from each part, at least you answer half of the question, or less than half of the questions, then definitely you will get 100 marks. Okay, that is qualifying JRF or qualifying net is not a big task if you prepare very accurately. There is I would like to convey. Now let us come to the electromagnetic theory part. This is our syllabus. In electromagnetic theory, we have the electrostatics and the magnetostatics. From electrostatics, we have to learn Gauss's law and its application. One question will be definitely there will be one question from this topic. Laplace and the Poisson equations, boundary value problems. From Biot-Savart's law, in magnetostatics, we will have a Biot-Savart's law, Ampere's theorem, Faraday's law of electromagnetic induction, then Maxwell's equation in free space and in medium, and then electromagnetic boundary conditions, the scalar and the vector potential, Gauge invariance, electromagnetic wave in free space, dielectric, conductors, capacitors, and there is some reflection and refraction of electromagnetic waves at a boundary. Then the motion of the charged particle in a static electric and magnetic field. Actually, these are the topics from the BSc Physics syllabus. You might have learned all these topics during your BSc. Most of the university, they will follow the book of David J. Griffith, that is Introduction to Electrodynamics. We are also follow the same book, Introduction to Electrodynamics. Studies on the special relation in plasma. I think we could not see any questions so far from this topic. Lorentz invariance of maximum location. Questions have been asked from this topic. Transmission lines and waveguides. We could see a lot of problems, means large number of problems have been asked from the waveguides and the radiation from moving charges, dipoles and tidal potential. Few questions you can see from this topic as well. Okay. The part C means for this question, you will get 5 marks. Fine. Now, so far, from 2011 to 2021, the total number of questions asked from the electromagnetic theory, that is from Coulomb's law, Gauss's law, and electrostatic potential, total 13 number of questions have been asked. Poisson and Laplace equation, electrostatic energy properties, 8 questions. Electric dipole, polarization boundary condition, 8 questions. Multiple expansion image problem, 11. Motion of charge particle uniform electric and magnetic field, be 4 questions. Bias of what law, obvious law. This was class. Magnetic rays free space 21. Reflection transmission 2 question. Okay, these are the from the wave guide you can see and potential formulation around 19 questions have been asked. Okay, here the vector and scalar potential will come. Gauge and Lorentz Gauge conditions, Gauge invariance will come here. Okay, these are the number of questions asked in the previous CSIR net examination. Okay, now let us move to our topic. That is, I will share another screen now. Fine. Okay, hope I think there is no doubts or clarification from what I said now. Anybody has any clarification doubt, you can ask me. Is it okay? Hello? Okay, fine. Good. Thank you. Now let us move to first one. That is an electromagnetic theory. We will learn Coulomb's law. From our 12th standard itself. But still, we are dealing the same, but it will be more advanced problems will come from this session. Well, recently in 2020, net examination questions came from these topics as well. Before going to the Coulomb's law, little bit mathematical equations that we have already learned in our early classes, but we have to recall that very few equations. Like if this one is a vector f1, another vector f2, this may be a Coulomb force, this may be an electric field, whatever be the vector quantity, then the resultant of this force, that is will be along this direction. Okay. This will be the resultant force or resultant vector. That resultant vector f, its magnitude, that is, we can write f is equal to root of f1 square plus f2 square plus 2 f1 f2 cos theta. Here, theta is the angle between these two vectors. This theta is the angle between f1 and f2. Okay. Most of in few cases we have to use this expression when we deal with the vectors. We should not add as a scalar quantity. This will give you only the magnitude of the force, not the direction. Magnitude of the force. And sometimes we will face some problems, like maybe the value of cos 60 degree. We may get confused with the value of the sine 30 degree. If you put wrong answer, if you put wrong values on post 60 degree, sine 30 degree, then that answer will also be there in the option. That is the one thing we are taking off. Therefore, if you come across any confusion on these values, the best thing is here I will do that chart. One can easily remember this chart. That is put theta into 0 degree, 30 degree, the most common angle that we will use in our calculation, 60 degree, 90 degree. And here, first you put 0 by 4, then 1 by 4, put 2 by 4, then 3 by 4, then 4 by 4, then under root, under root, under root, give a square root. Next, here you write sine angle, sine 0. Before that, I will reduce this value. This value is 0. This is 1 by root 4 means 1 by 2. 1 by 2 means 1 by root 2, its value. This is root 3 by 2. This is 1. Now here you write sine theta value. This sine theta, that is here sine 0. This means sine 0 is 0. Sine 30 is 1 by 2. Sine 45 is 1 by root 2. Then this is value sine root 3 by 2. Sine 60 is root 3 by 2. Sine 90 is 1. Then cos theta is the reverse, right? Start from here. That is cos value will be 1 root 3 by 2, then 1 by root 2, then write this value here, 1 by 2, 0. Okay. This table will be quite useful in many cases. That is, we have studied in our early classes, but still it is useful. And some other information like cos 120. That will be, we have to write it as a cos 90 plus 30. That is cos A, cos B minus sine A, sine B. Like this information also we need to remember. Okay, straight away one cannot find out cos 120, but you can write that cos 120 to this fashion, and from this table you can substitute the value in this way. We have to use this identity in our calculations. Some other information we need to know is for if this is a square, then its length is A, then this length, that is root 2A. Okay. If this is a cube, if this is a cube, sometimes we need to remember the length of this one, that is root 3a, if a is the side of the width. This kind of little bits mathematics that we should remember, then the problem solving will be quite easy. Okay. Now let us come back to the Coulomb's law. Everybody knows the statement of Coulomb's law. That is, once again, I write the heading, Coulomb's law. That is, if there is a charge Q, we call it as a source charge placed at this point. We know that there will be electric field lines emerging away from this positive charge. In this electric field region, we place another small charge Q. This we call it as a test charge. The force, we know that this is a positive charge, this is another positive charge. Whatever the force, that force will be, of course, repulsive force. The charge will be repelled away. We observe on this charge what happens to this charge. That is a force experienced by this positive charge. That we can write F is equal to 1 by 4 pi epsilon 0 q divided by r square, where r is the distance between these two charges. Okay. To make it a vector quantity, we will write as a vector symbol. And the value of this 1 by 4 pi epsilon 0, we need to remember this also. 9 into 10 power 9. And here, this epsilon 0 means these charges are kept in free space. This is a force in free space. All of us know all these things. In medium, this force get modified. That is, this F will be 1 by 4 pi epsilon q divided by r square r cap. Okay. This epsilon is the permittivity of the medium. Permittivity of the medium. We know the relation between the epsilon r, that is epsilon by epsilon 0. We will call this is the relative permittivity. Just I recall whatever we have studied in the earlier classes, or we call dielectric constant. Now, these are the story of about the forces. Now, what I would like to convey is how we can represent the direction of, or how we can find out the direction of this force. Okay, that is the direction of Coulomb force, because this is most important by solving the problem. Direction of Coulomb's force. That is, if we place two positive charges, plus q1 and 2 plus q2, plus q1 and plus 2, two like charges. They are separated by a distance r. We know that the like charges repel. That is, if you look at this charge, the q2, where it will go away, this charge will repel away, means its direction will be along this direction. That is, we use this convention This arrow mark we use for the repulsive force. This is the person two charges are moving away from each other. That is repulsive force. For an attractive force, we will put the force arrow like this. Attractive force. Okay. Then this force is represented by, this is a force experienced by charge 2 because of the charge 1. That is, here the F21 means force on Q2 by Q1. That is the first letter. The charge placed at 2, that is Q2, experience this force. That force is exerted by Q1. Now, if you look at the second charge, the first charge, because both are the positive like charges, this will also repel away. And the force experienced by this charge is F, force experienced by charge 1 because of 2. That is F12 is the first letter that the charge 1 experiences the force. It's force on Q1 by Q2. Okay, this is one idea. Now, direction you can determine in this fashion. Its magnitude that you can calculate using the expression F is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by. This is only for the magnitude. Now for a negative charge, this is a minus Q charge, minus Q1. This is a plus Q2. Separation between the charge same R. Then the charge Q2, that's a positive charge, that you will experience attractive force. This charge will move this direction, and this charge will move this direction. Then is you can see that this is a representation of an attractive force. Come close to each other. Okay. Then this force is force experienced by charge 2. This force is exerted by charge 1. This is the direction of the force experienced by charge 1. This force is exerted by charge 2. This is a representation of the attractive force. This is a representation of the repulsive force. And this is a notation F12 and F21. Now let us do a simple problem. That is a very simple question. S square. Believe that this is a square. Square. Here, 5 Q charges are placed at this end, and here 5 Q charge. At the end, at this corner, we have minus 2 Q charge. In this corner, minus 2 Q charge. At the center, we have a Q. That is, this is a plus Q charge, capital Q. Side length is A. We need to calculate the net force on Q. This is the charge Q. Okay. Without doing any calculation, one can easily predict the force experienced by this charge. That is, here, first, the net force on this Q means this charge exerts a force on this Q. That is, both are positive charge. Therefore, this charge will be repelled away. I can draw a vector like this because both are positive charge. But one thing the length of this vector that is determined by the product of the charges and the separation between the charge. Okay. All of the charge are situated at the same distance from the center charge Q. Distance are same. This Q into 5Q means that force will be 5Q into Q. Some 1 by 4 pi epsilon 0 is there. I put it again. This distance is something we can write it as if you put it as A, B, C, D. That distance will be A or square. Then this is the magnitude only. The direction is along this direction. Then the force on the same charge Q due to this 5Q charge. Force between this and this. Both are like charges. That is, this because of the force of this Q, that should be this charge will be repelled away in this direction. But the length of the vector should be same. Both should have the same length because the magnitude of the force is same. Say this is the force between this charge and this charge. Now the force on the plus Q charge due to this minus 2Q charge. This one is a positive charge, this one is negative charge. Therefore, this will be attracted to this direction. One can write this is a force experienced by the charge placed at the O center due to charge placed at B. One can write this force. This is a force experienced by charge O because of the charge placed at C. One can write this force is a charge experienced by the charge placed at O because of the charge placed at C. Sorry, this is A. Force experienced by charge O into A. This is force experienced by charge at O due to C. And this one, this is a negative charge. This is a positive charge. Attractive force. That is, this charge will move along this direction. The length of these two vectors should be same. Therefore, these two will cancel each other, and this will cancel each other. Net force is equal to net force. F net will be 0. That is, by looking at the direction, one can predict the net force will be in what direction. That is one thing. The same idea can be applicable to find out the net electric field. One can decide the direction by looking at the direction of the force or direction of the vector quantity. Okay, I hope this is clear to you. And next, we will move another small problem. That is, there is an equilateral triangle. Equilateral triangle whose side is A. Charge placed at this point is plus 2Q. At this point is minus Q. And here this point is Q. Okay. Now, we need to calculate the total force on find total force on the charge Q. To solve this problem, let us give some values. One of the values here is at point A, this is B, this is C. Then net force on the charge Q. That is our A. We need to find out what is the net force of the charge Q. or we can say that force on the charge placed at C. For this, first what we have to do is we have to draw the net force on the charge. This Q means force exerted by the charge 2Q on Q plus force exerted by charge minus Q on this Q. Okay, that is, we can draw the vectors symbol. Force direction we can draw here now. Force on the charge small q at this point is both are the positive charges. Therefore, the small q charge will be repelled away along this direction. Along this direction. This is the force experienced by the charge placed at C because of the charge placed at A. Then at Q, at the point C, there is another charge minus Q will exert a force. But the magnitude of these two charges are same. That is small compared to the magnitude of this charge. Therefore, the length of the vector should be smaller. Let us see the direction also. One is positive, one is negative. Therefore, this charge will be attracted to this negative charge, towards negative charge. But the length should be smaller. That is this force. The force on C because of the charge placed at a B. This should be, length should be smaller. Then one can easily predict that the resultant force will be along this direction. Okay. This is the resultant force. That is a net force on the charge at C. That's FC. Then to find out the magnitude, we can use net force FC is equal to, there are two forces, one is FCA, another one is FCB. All are vectors, therefore we can use this value, FCA square plus FCB square plus 2 FCA to FCB cos theta. Okay, this is now we can find out what is FCA, the magnitude of FCA. FCA means force between this charge and this charge. That is, let us put 1 by 4 pixels as a K into Q into Q. Q into 2Q divided by A square. That is, one can easily write 2K Q square by A square. Now here we don't need, don't bother about the direction. Direction we have already considered. And the force FCB is K into, here, while writing this force magnitude, we should not write this minus sign, because the effect of this minus sign we have already included in this direction. Therefore, one should not write minus sign here. That is, Q1 is this Q, Q2 is this Q. That is K Q square by A square. Now, let us substitute this value here. Another thing we need to find out is cos theta. That is, what will be the value of cos theta? This cos theta is the angle between FCA and FCB. That angle is this angle. This angle. Can anybody suggest what will be this angle? Anyone?
120, sir.
120. Yes, very good. 120.
180 minus 60.
Yeah, yes, 180 minus 60. Because this is an equilateral triangle. My picture may not be looking like an equilateral triangle, but this is an equilateral triangle. Each angle will be 60 degree. This will be 60. This will be 60. And if you look at this pattern, this is our triangle, and this is 60, and this will be 120. Then only the total angle will be 180. Okay. Therefore, this angle is 120 degree. Good, correct. Then we can substitute all these values here. That is f c is equal to. For the moment, I'll omit this k because k is common in all the first time. Just I will write this as a 2 FCA is equal to 2 q square by a square plus FCB q square by a square plus then 2 in FCA again 2 q square by a square here 2 sorry q square by a square into now the problem is cos 120. Cos 120. One can write cos 120 degree as a cos 9 plus 30. That is cos A cos B plus cos minus sin A sin B. This value 0. Then sin 30. This is 1. Sin 30, somebody maybe some confusion whether it is a root 3 by 2 or 1 by 2. For those, they can write like this. Our sin 30 is 1 by 2. Okay. This is 1 by 2. This is minus 1. Okay, minus 1 by 2. Therefore, our force, the magnitude of our force, this one, 2 q square by a square, q square by a square, we can write 3 q square by a square minus this
K
2.
q square by a square, sir. Answer.
Yes, k is there. That is common in all the time. But for the easiness of writing, just I omitted that one. I decided to add that at the final stage.
Okay, sir. Thank you, sir.
Okay. Fine. Then here, this half and half would cancel. Here, yeah, I committed a mistake. Actually, this should be force square. Just here we have substituted the force only. That should be squared. Okay, that should be squared. Sorry. Then this expression 4 q raised to 4 by a raised to 4 plus q raised to 4 by a raised to 4 minus 2 q raised to 4 divided by a raised to 4. Okay, this is a 4q raised to 4 by a raised to 4 means 5q raised to 4 by a raised to 4 minus 2. That is 3q raised to 4 by a raised to 4. Here now we can add that to k. That will be k square will be there. One can write this as a something like root 3 k q square by a square. Yeah. Did I anything wrong? Any issue? Is it fine? Anybody? Okay.
Yes, sir, it's correct, sir.
Okay, fine, fine. Actually, this is a magnitude only. This k we can put 1 by 4 pi epsilon 0 root 3 q square by a square. This is the direct magnitude only. But most of the times, since this is a force, one has to write the direction as well. To write the direction, we have to look at that picture. That is, our net force is along this direction. That is, if you uh, take this is the x direction, this is a y direction. The net force Fc is along x direction, positive x direction. Then that you can mention here. Now your force is a vector quantity. This is the way of doing the problems, especially the vector quantities like a Coulomb force. What we did is we consider this negative and positive sign in calculating determining the direction, and magnitude we calculated using this expression. And finally, to give the direction of the force, we uh, followed in this technique. Okay. And once you have considered the direction for the direction of the force by taking this negative charge sign, once the direction is included by looking at the sign of the charge, then again should not we put the minus charge on the force equation. That will give an incorrect answer. Okay. Now what I am, though this Coulomb force we are learning from the +2 classes onwards, but still in 2020 CSIR net, they have asked one question. That is we are going to do next. That is CSIR net in 2020. I will paste that question here. Okay, this was the question. 3-point charges Q are placed at the corners of an equilateral triangle. That is the same equilateral triangle. Okay. 3 charges, each having the charge Q. Q. Another point charge minus Q is placed at the centroid of the triangle. Centroid means if you draw a line exactly perpendicular to the other side, draw lines from each vertices to the middle of the other side. Then this point will be the centroid of the triangle, where a charge minus Q is kept. minus q is kept at this point. If the force on each charges q vanishes, that is, if somebody find out the net force on this charge or net force on this charge because of the other charges, that force is zero. That is the meaning of this. Then the ratio q by q is what? That is a question. That is, to solve this problem, let us label these vertices. So one can write this is 1, this is 2, this is 3. Um, there is we need to find out the net force. We need to find out the ratio, but the given information, what information is given, that is this one. So if the force on each charge q vanishes, means total force on any of the charge, that will be 0. Then I consider um, the charge placed at the point 3, the net force on this charge, I am going to calculate. Okay. That is, one can easily write that force. If you look at this charge 3, force on this third charge due to this charge 1. What are the like charges? That for this charge will be repelled away along this direction. This force is force experienced by charge 3 because of 1. Next, the force on charge 3 because of these 2. Both are like charges. This will be repelled away along this direction. The length of the force must be same because both are having the equal magnitude. Distance is also same because equilateral triangle. This is a force experienced by charge 3 because of 2. Okay, I write in this direction. Yeah, F3, 2. We know that it's mentioned that net force on this third, any charge, we consider the third charge. The net force on this third charge is 0. Now, net force means force on this third charge means force exerted by charge 1 on 3, force exerted by charge 2 on 3. Then another charge is there, minus q charge. This minus q charge exerted force on charge 3. Its direction, that is attractive force. Because of the minus q charge, this charge will be attracted along this direction. The movement of this q charge or the direction of the force on the q because of the minus q will be along this direction. This is the force experienced by charge 3 because of the charge q. Okay. Then, which means if we all vectorially all these 3 forces, that total force equal to sum of all these forces is equal to 0. That is the meaning of this statement. Next, what I will do is we have to add all these 3 forces. If there is a force like this, this one is F31, this one is F32, then we know that the resultant force will be around this direction. Sorry. Along this direction. If this is our third charge Q, then this will be the total of forces experienced by charge 3 because of the 1 and 2. Let me draw that force here. This is the force experienced by charge 3 because of these forces, these 2 forces. Now our problem is reached at this level, we have to find out these F3 force and one force in the downward direction, that is this F3Q. Okay. These forces are equal and opposite. That means one can write this force F3 is equal to F3Q. Or one can write equal and opposite, means based on this question, if you write total force on charge Q at 3, that is F equal to F3 plus F3Q 0. Or I'm not going to confuse. One can easily write from this picture, that is, we can follow this method. Equal and opposite, that is F3 is equal to F3Q, because both are opposite direction. Now we will get the answer if you find out these forces. That is, I am first going to find out the force F3. If you look at this picture, this is our F3, and these are the two forces responsible for this force F3. That F3 is equal to the magnitude that we can write as a F32 square plus F31 square plus angle between these two. Okay. What can anybody tell what will be the angle between this F32? Actually, this is under root. What will be the angle between F32 and F31? What is it? 2 factorial meter. Can anybody tell what is the angle between this? This is an isosceles triangle. Isosceles triangle, and each angle will be 60 degree. Therefore, this will be 30 degree. Then
60, sir.
This one 60 or 90. At this angle. This angle we know. Is it 90 degree or 60 degree?
90 degrees, sir.
90 degree. Actually, yeah, this angle will be 90.
Sir, please explain how it is 90 degree.
Yeah, it is not 90. How did you get, how we can calculate this angle? Actually, my teacher,
See, it seems to be 60 degrees.
yes,
The
60.
angle between F21 and F32 and F31, it should be 60 degree.
6 degree, yes. That is because if your triangle is perfect, because my drawing is not that much perfect. If you write a perfect triangle, one can easily identify without doing the calculation. This will be 60 degree. Otherwise, Yeah, this will be the 60 degree. Then what will be the, can you do this one? F32. F32 means these two forces, that is one can, like previously, we did these two force between these two charges. This one is Q and this one is Q. K Q square by A square. This force is K Q square by A square. And sorry, these two both are the same. This is also K Q square by A square. Then F32. Again, same value we can substitute here, and this theta is equal to 60 degree. Then I think almost a similar problem we have done. Therefore, no need to go for the calculation again. For that was 120 degree, like fine. What is cos 60 value? Cos 60.
1/2, sir.
1/2. Okay, fine. Then you substitute all this value. Could you please final answer of this force F3? I think that you can do yourself. Okay, shall I write the answer now? Or to save the time, I will write this will come around 3k q square by a square. This force F3. Okay. Actually, this force F3 that is along this direction. F3 is along the negative direction and upward direction. Now, next our problem is to calculate this force. That is the force along this direction. That is F3Q. For this, our minus Q charge is kept here. This point, if you write the expression, that is here you have the Q, here the minus U. Then for F3Q, K into Q by the distance between these two charges. One can write this is a point A. Okay, I use some other color. This is I put A, and this I put C. This I put B. That is A, B, C. The distance between these two charges, 3Q and sorry, minus Q and Q. This distance, that is AC. KQ divided by AC square. But here we should apply some algebra to calculate this AC square, this AC. Okay. Now our task is to find out the value of AC. From the figure, one can see that AC, this AC is equal to, one can write from AB minus BC. Because one can easily find out the AB. This length is AB. One can find out the AB because already know this is the side A. Then this AB is equal to root of this A square, this side square, half of this side square. Or we can, okay, to find out AB also we need some calculation. That calculation is this one. AB is equal to root of A square, hypotenuse square minus this square, A by 2 whole square. That is equal to root of A square minus A square by 4. That is finally 4A square minus A square, root 3A square by 4. That is root 3A by 2 will be the answer of AB. Now we obtained AB. Now what about BC? BC we know that is from mathematical. If you look at the for the centroid of a triangle, the distance from the middle of this point to this centroid, that is this BC, that is will be 1/3 of this AB. 1/3 of the AB. That is a non-factor. That AB side we have already calculated. That is root 3A by 2, this quantity. Then BC will be equal to root 3 will be cancelled. That is we can put as it is because maybe later stage that we will cancel. We can keep as it is. Then we can substitute. Now BC is ready and AB is ready. We can substitute here. AC is equal to AB minus BC. Root 3A by 2 minus 1/3 root 3A by 2. Root 3A by 2 is common. One minus 1/3. That is root 3A by 2. 3 minus 1, 2/3. 2 go to cancel. Then we will get A by 2. That is the value of AC. Where we have come from, yes, our aim was to calculate this AC. We got the value of AC by just to substitute here. That is F3Q is equal to KQQ divided by AC square means A by root 3 whole square. Fine. F3Q KQQ and 3 by A square. Good. Here 3 KQ divided by A square. Now we obtained the value of F3QQ and we obtained these two values, F3 and F3Q. Just write that value here. 3 KQQ by A square equal to root 3 KQ square by A square. Okay. Or cancel 1Q, 1Q, A square cancel. 3, this will be root 3. And in question, it was capital Q by Q. That was our question. Ratio of capital Q by Q. Capital Q is here. Small q is here. 1 by root 3. Yes, 1 by root 3. I think option B is the correct answer. 1 by root 3. I hope this is clear to you. And here we have adapted this to the vector rules. how to handle the vectors. That's we have adopted here. 1 by root 3 is the answer. Fine. Similarly, this problem is we have done is little bit lengthy because we should not think that simple problems may be asked. What little bit effort may be there to solve that problems. But if you we will give you the problem sheet. If you try yourself, then you will be master in solving this kind of problems. Then let us go to another simple problem, because you must do all the problems from the Griffith textbook. Then you can solve any type of problems, because Griffith textbook is a standard book for studying this electrodynamics. This is another problem. 12 equal charges. Sorry. 12 equal charges situated at the corners of a regular 12-sided polygon. This is a 12-sided polygon. My pen. Okay, fine. One each numeral of a clockwise. Here one Q is placed, another Q is here. Like 12 Q are placed at each corners of a 12-sided polygon. What is the net force on a charge Q at the center? If a charge Q is kept here, then what will be the net force on the charge? If R is the distance from the center of each number, if this is a distance from the center of each number, what will be the force on this capital Q charge? Then without doing any calculation, we can easily find out force on this Q charge because of this small q. That is, one can write this is the positive charge, this is a negative positive charge. The force of repulsion will be there. That is, this will be the force in this direction because of this charge. And because of this charge, the force on this charge will be this direction. Similar way, force on this Q charge because of this Q. That will be the force will be actually along the rays, along the radial direction. The length of the force will be same. Okay. If you calculate the force on each charge from the other charges, one can find that the force will be cancelled by each other. My pen some issues now. This force and this force got cancelled. This force and this force got cancelled. This force and this force got cancelled. Okay, that is the net force on the charge will be zero. Okay, remember that if the number of side of the polygon, if there are charges according to the number of charges, or if there are 12-sided polygon, and if there are 12 charges, then the net force will be zero. If any one of the sides is 7 charges there at the numerals, then the total force acting on this capital Q charge. Can anybody tell what will be that force? That is, from the 12 charges, 1 charge is missing. Then what will be the net force on this charge Q?
force due to only one charge, sir.
Yes, exactly. Very good. Good. Because other forces will cancel out each other. This force and this force would cancel out. But there will be one force without cancelling. That means if you consider this charge, that is a force around this charge. But to cancel that force opposite direction, there is no charge here. Therefore, this force will not be there. Therefore, this force would cancel out. This all will cancel out. But only these force will be left out. That force, because of this only one charge, that force will be equal to 1 by 4 pi epsilon 0. This small q and capital Q divided by r square. Its direction is along this direction. But here the magnitude is only asked. Okay, that is the thing. Whatever be the polygon, for example, S square. S square. There are charges will be there, like Q, Q, Q. Another point charge will be there. Total charge will be 0. And if any one of the charges is missing, then what will happen is force between these two will be around this direction. Force between this and this will be around this direction. That will cancel out, but this force will suffer. We need to calculate only this force. That is the thing. Number of number of charges is equal to the number of sides of the polygon. And that charges, if the charges will be equal, that's one more condition. All those charges should be equal or opposite. Then net force will be 0. If any one of the charge missing, that missing charge will give us a certain force there. That way we can easily find the force. A lot of problems are there. This kind of now I have taken a very simple topic only. And tomorrow, in the next class, we will go ahead with some advanced problems. If you have any doubts, clarification, you can ask to me. Is it clear? Anybody has any issue? Yeah, already somebody answered in the chat box when I answered the arrow. Okay, sorry, I don't see that one. Now I see. Okay, thank you very much. Classes. Amit Parida has one course. Sir, classes will be in 2 batches from 12. That is not 2 batches. That is tomorrow you will have 2 subjects. That's all. Because as you know that this CSIR net syllabus, we study those full whole syllabus in the 2-year MSc courses. That that we are going to cover in certain hours. Therefore, in 40 days, we need to conduct 2 subjects each day. Then only we can cover most of the topic. That is why tomorrow there will be 2 classes, one from 7 to 8:30. Then you can take rest for 30 minutes. Then from 9 to 10:30 we will have another class. Okay, I hope this is clear. Meenachi Prakash has said we need a PDF, sir. Sure, I will make it a PDF and I will send to you. And tomorrow morning we will send you problem sheet also. Amit Parida asked. Okay, let me check. Actually, I attend the class from college and I can't remain here past 9:15 p.m. So I attended the first class. Okay, Amit Parida. Okay, no issue. You can watch the recorded video. Thing is, we we have chosen this time because somebody is working and there somebody are doing research. A lot of problems are there. That's why we have considered this timing. Uh, no issue. You can watch our recorded video and also you can ask to us your doubts clarification. No issue. We will conduct separate doubt clearing session, completing certain topics. If in one subject, if we complete a few topics, then we will conduct doubt clearing session. Okay, thank you. Thanks to all. Let us meet tomorrow. Thank you very much. Good night.